How to design an efficient electrical circuit. 1. Define the purpose and requirements. Start by clearly defining the purpose of the electrical circuit and its requirements. Determine the desired output, the input power source, and the specific functions the circuit needs to perform. Having a detailed understanding of these aspects will guide your design process and ensure that the final circuit meets all necessary specifications. 2. Create a schematic diagram. Develop a schematic diagram of the circuit using design software or on paper. The schematic should include all components, such as resistors, capacitors, inductors, transistors, and integrated circuits, and show how they are connected. A clear and accurate schematic is crucial for troubleshooting and optimizing the circuit. 3. Select appropriate components. Choose components that match the circuit's requirements in terms of voltage, current, and power ratings. Use high-quality components to enhance reliability and efficiency. Ensure that the components are compatible with each other and the overall design. Overrating components slightly can provide a margin of safety and improve durability. 4. Optimize power consumption. Design the circuit to minimize power consumption. Select energy-efficient components and consider using low-power modes where applicable. Optimize the circuit layout to reduce resistance and heat generation, which can lead to power loss. Efficient power management is essential, especially in battery-powered devices. 5. Implement proper grounding. Ensure that the circuit has a proper grounding scheme to prevent noise and interference. A good grounding system provides a reference point for voltages and helps maintain signal integrity. Avoid ground loops by having a single ground point and using short, thick ground wires to reduce resistance. 6. Use decoupling capacitors. Place decoupling capacitors close to the power supply pins of integrated circuits to filter out noise and stabilize the voltage supply. These capacitors act as local energy reservoirs, smoothing out fluctuations and ensuring that each component receives a clean and stable power supply. 7. Plan for heat dissipation. Design the circuit with proper heat dissipation in mind. Use heat sinks, cooling fans, or thermal pads for components that generate significant heat. Ensure adequate ventilation in the circuit enclosure to prevent overheating, which can reduce efficiency and damage components. 8. Simulate the circuit. Use circuit simulation software to test and analyze the circuit before building it. Simulations can identify potential issues such as voltage drops, current spikes, or oscillations. Adjust the design based on simulation results to optimize performance and ensure the circuit operates as intended. 9. Build and test a prototype. Construct a prototype of the circuit on a breadboard or a prototype PCB. Test the prototype thoroughly to verify that it meets the design specifications. Check for proper operation, signal integrity, and absence of noise or interference. Make necessary adjustments to improve performance. 10. Optimize the final layout. Design the final printed circuit board, PCB, layout with efficiency in mind. Arrange components to minimize the length of connections and reduce resistance. Use appropriate trace widths for current carrying paths and ensure that power and ground planes are properly implemented. A well-designed PCB layout enhances the circuit's overall efficiency and reliability.